In this video, we're going to look at the properties of definite integrals. So I want to remind you this is definite integrals, not indefinite integrals. And it's how we're applying algebra to integrals. So the properties of definite integrals, most of these are the result of applying, like I said, algebraic properties. So the first one is that if we integrate a function from a to a, in other words, there is no, the upper and lower bound are the same. It doesn't matter what that function is, the result will be 0. And this kind of makes sense because if you think about it, as far as a graph, if you try and find the area from this point to this point, it has no width, therefore it has no area. The integral from a to b of f of x dx is equal to the negative integral of b to a of f of x dx. So this is just saying if you switch the bounds, the result is going to be negative. And the way you can kind of think about this is it's basically working backwards, which means all of our widths, instead of being positive widths, now they're negative widths, so I get a negative value. Next we have an integral rule with sums, so a, b, and if I have f of x plus or minus g of x dx, that's going to equal the integral from a to b of f of x dx plus or minus the integral from a to b of g of x. So in other words, addition and subtraction, I can either add or subtract the functions before I take the integral, or I can split them up into multiple integrals and integrate them each independently. Exactly the same as with derivatives, just with integrals. If I'm integrating from a to b and I have some constant times a function, I can pull that constant out and then integrate just the function. And this sort of makes sense because if you think again about that area, if I'm just making each box twice as high, I can, instead of multiplying each box times 2, I can just find the total area and then double the height at the end. And then lastly, this is the most interesting and useful one. If I integrate from a to b of f of x dx, I can split that up into the integral from a to c of f of x dx plus the integral from c to b of f of x dx. So in other words, I can split up any integral into any points that I want. The most common place you'll see this initially is with a, b, and c values like this. A, b, and c in the middle. So in other words, I can integrate for half of it and then integrate the second half. But what's cool about this is that that c doesn't need to be in the middle. It can be before a or after b, and as long as you still apply this, it will work out. Basically what ends up happening is if it's before a or after b, one of these integrals ends up being negative to kind of subtract off the extra bit that you've added by going past your point. So these, again, are things that in practice you'll start to see where they apply. I'll be there to answer questions and help talk you through them.